Hello, everybody. So, we're going to continue talking about logarithmic and exponential equations today. And we're going to be solving logarithmic equations using what we learned last week on converting them between exponential and logarithmic. So at first, this will look very familiar. It'll basically look like what we were doing last week. So I'm going to start by putting that conversion back on the board. Okay. So this is the conversion. This is the same thing as this, just written as a logarithmic versus written as an exponential. So, for our first one, if we write something like log base 5 of x equals 4. For a problem like this, all we really have to do to solve it is to convert it. So if we line it up, should have lined it up to begin with, oh well. What we've got, b equals 5, a equals x, and x equals 4. Okay? So that converts to b, 5, x, 4, and then a is x. And boom, when we've converted it, we've solved it, right? X equals 5 to the 4th. Now you just got to know what 5 to the 4th is, right? So that's 5 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So your conclusion is that x equals 625. And boom, we've solved it. We basically did that when we were converting between them the other day too, except I didn't ask you to tell me explicitly what x equals. I just wanted you to rewrite it like this. Okay? So, pretty easy, pretty straightforward. And we do another one. What we didn't practice is ones where you're missing the base, but it'll still work out. Watch this. Log base x of 49 equals 1/2. So if we rewrite that, first, what's my b, a, and x? So b is the base. So in this case, base is x. A, 49. And x, 1/2. So over here, b is x. X is 1/2. And a is 49. I wrote this not how I intended. That's okay. Okay, so x to the 1/2 equals 49. So you might be thinking, well, what do I do from here? Here's what I need you to remember. Do you remember when we practiced cube roots? And we talked about how cube root of x is the same as x to the 1/3, right? We mentioned that, it was on the test, etc. Likewise, x to the 1/2, it would be the second root of x, which is square root of x. Okay? Square root of x equals x to the 1/2. Beautiful, right? I think so too. Okay. So if we think of this as square root of x equals 49, square root of x equals 49, How do we get x by itself? Yes. Cancel out a square root by squaring. And when I was writing it, I was thinking the opposite, and I was thinking square root of 49 is 7. But instead, we got to find the square of 49. I have faith in us, though. That's just like 7 to the 4th. 49 times 49 is 44. 6, 19. 2,401. Getting some big numbers here. So we squared both sides, and we got 2,401. So if you ever have to the 1/2, that's the same as square root. Just like to the 1/3 is the same as cube root. Okay? So those are fairly basic ones. We can get a tad bit more complex, but still not too bad. Still just solving. Okay. So what if we said log base 4 of 9x minus 14 equals 4. So my b is 4. My a is this whole thing, 9x minus 14. And my x is also 4. Okay? So rewriting it, b is 4. X is 4. And a is 9x minus 14. So we got to find out what 4 to the 4 is. 4 to the 4th power. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. So 256 equals 9x minus 14. And from here, we can just do our regular two-step solving, right? How do you get x by itself? Add 14. $270. And last step to get x by itself. $270 divided by 9 would be 30. Because 9 times 3 is 27. Pretty good, right? We converted it to exponential and then found a way to solve it. Because logarithms are weird, right? So once you convert it to exponential, you kind of know where you're at. Okay, let's do a couple more. All right, log base 2x plus 3 of 343 equals 3. Lots of 3's there. So base is this whole thing, 2x plus 3. A, 343, and x, just 3. So converting it, base, 2x plus 3, x equals 3, and a is 343. Okay, So we've got 2x plus 3 to the cubed equals 343. So what can we do to get x by itself? This might be tricky for some people. So if you had x squared equals 9, you know how to get rid of that square. We do a square root to cancel it out, right? Get x equals 3. Keeping with the 3's thing. So, just like that, if you recall on my prior assignments, I had all those questions where one option was cube both sides and one option was cube root both sides, and I got a lot of questions from people being like, what's the difference, which is which? And most of the time on those, we were practicing with cube root equations, so the cube root was already there. So the answer was you had to cube both sides to get rid of the cube root. Here, it's already cubed. So we would do this. To get rid of the cube, we would do a cube root. So this is when you would take the cube root of both sides. So cube root and cube cancel out, and you're left with just 2x plus 3. Cube root of 343, probably want to do that in the calculator. Remember, you can write it as 343 to the power of 1/3. And you should get 7. Now I've just got a lovely familiar two-step equation. I'm going to subtract 3 from both sides. And 2x equals 4. Lovely little x equals 2. So that is another example. We use cube root to cancel out cube. Okay. And then the last one I want to do is slightly different, but possibly even easier because it hardly requires anything new. If I had, this is just to cover my bases, if I had log base 6 of 5x plus 2 equals log base 6 of 2x plus 11, notice these have the same base. So if you recall when we were doing exponentials, if you had 6 to the, what am I thinking? Anything. 6 to the x equals 6 to the 5. Then when the bases were same, we could set the exponents equal to each other, right? We did that last week. Likewise, the bases are the same, so we can set these insides equal to each other and just solve from there. And what's the right first step for this one? There's 4 different options. The possibilities are endless, and by endless, I mean there's 4 of them. Okay? I usually subtract the smaller x term first. No particular reason, that's just my habit. 5x minus 2x is 3x. And now, we got to get the numbers to the other side. And finally, we divide. We get x equals 3. So that's all some examples of logarithmic equations. And now you can try some yourself, you lucky ducks.